All right, awesome. And thank you, everyone. Thank you so much for these wonderful introductions. And we'll be going straight to, the questions that we have for you. And I hope everyone who is on this call will learn so much from you all. All right. So,
So
all
just a
right.
quick
So,
one. Just a quick
yeah,
one. If
yeah.
I just wanted to put a top, just a topper on it, is that I
So,
think on a higher level is that AI has sort of changed how it's changed the question of how do we model and govern data to more about how do we design systems that can reason and act on data basically. So yeah.
awesome. Yeah, cool, cool. Yeah, thanks for sharing. All right. So, I'm going to be targeted about my questions. So, don't be a question of who to start first, right? And Toby, you actually go first this time. All right. So, what does AI delivery look like at scale? And what skills can help engineers stand out in enterprise environments?
Good question. AI delivery at scale. So I'd say just like any sort of delivery at scale, I'll sort of break it down in two ways. The first one is around infrastructure, and the second one is around sort of operational sort of complexity. So with infrastructure, you're looking at, so a lot of clients I work with, for example, you want to implement or you want to embed AI into a particular area of your business. You're looking at things like legacy systems, for example. How do we sort of work with those? How do we sort of make sure that our data pipelines are sort of working well? So that's just from the engineering side. So like when you're dealing with sort of models that have like loads and loads of requests. So for example, you're working with a bank that has, let's say, 2 million customers. That is completely different from like working on like a really small project.
Yeah.
Then you have the operational side. So for example, how ready is your organization for this particular type of change?
Yeah.
What are the potential sort of governance requirements, potential regulatory requirements? How do you make sure you eliminate bias from your models that you're building? So at scale, those are the sort of two strands that are trying to sort of juggle: the sort of operational side and the sort of infrastructure side. I sort of have to sit and sort of juggle with both. I would say like engineers mostly have to sort of worry about the sort of infrastructure side, and some others have to sort of worry about the operational side. I sort of have to worry about both. But I think from a AI at scale, just like with any delivery, those are the sort of two main buckets. And the next question was around, I think you mentioned engineers. What do engineers have to do?
Yeah.
I think the big difference now, and Daniel touched on this somewhat versus many years ago, or at least when I started. So when I first started working, if you were an engineer, you had to just come in, you had to know how to code, and pretty much that was it. You didn't have to worry about anything. If you could code, you could work for a long time. I think now it's different. When I hire engineers, I'm not just looking for people who can code. I'm looking at people who, for example, understand the business. So, which is something that I would have never done. So I need to know that you actually know the actual business that we're going to be working on. I need to know that you know how to sort of work with other engineers, work with other teams, whether that's business teams, whether that's data teams. So those are like different skills. I need to know that you understand systems. I think that was another thing Daniel touched on. So that's systems knowledge, not just coding ability. I would pick someone who has very deep embedded systems knowledge over someone who just has just pure ML expertise and just that's all they could do. So I think those are you need a broader skill set today to be a software engineer than I think you've ever done.
Yeah. Could you clarify the difference between the embedded systems which just you spoke about and ML systems, just so that our audience can be clear about that difference?
So so when I say just ML knowledge, so I guess obviously you understand machine learning.
Yeah.
And when I'm talking about broader systems knowledge, it is how do we take, for example, this model? How does this model interact with this particular legacy system? How does it work with this part, this application? So it's a broader skill set than just I'm coming down, I'm just going to sit down and just write some code. So that's what I mean by sort of a broader skill set.
All right, makes sense. Thank you so much. So, and if you're, this question is for you. How do data foundations shape successful AI systems, and what mistakes do early engineers often make?
Now, that's a very, very important and very vital question. And I think I touched a little bit of that in my introduction, is that there is first data before you think about AI, right? And so I'll just, expatiate on that. Now, typically, strong data foundations is typically the difference between AI that demos well and AI that works in production. And I think that's what Toby was also trying to, spotlight there. Successful AI systems are basically built on data that is trusted, that is well governed, that is, and has business value as well. At the end of the day, you want to, if you feed AI systems with inconsistent data, all you're going to get is you get AI amplifying the noise in your data. And then you hear about concepts like AI hallucination. AI is hallucinating because it doesn't have the context, it doesn't know the right context. And which is where we then talk about, context aware synthetic data. So it's a very important concept in AI systems. We have to first understand data and systems, which is another point that Toby also touched on. One of the biggest mistakes I think early engineers actually make is treating AI as a model problem rather than a data or a system problem. And this is what happens. Like, we just jump straight into like LLMs and ML frameworks without stabilizing upstream data, right? AI ends up, like I said, it just amplifies the noise, the bias, the inconsistencies in your data. That common mistake I think that we typically make is, for example, now giving an example in the use cases, I can build a chatbot here, I can build a model here, but there's no shared semantic layer. There's no feature store, no observability. I think these are also things that early AI engineers also miss when building or working with AI systems, is that you have to build with, semantic knowledge. For semantic understanding, you have to also embed observability, as a matter of fact. And it makes it impossible to scale or govern AI without these, individual components, basically. And finally, I think another thing also, as speaking as a data engineer now, is that people underestimate change, right? Changes happen, data changes, schema drifts, right? Business definitions evolve. And so, but AI system typically always will, is built, people often build data AI systems as though the data will be static. But in reality, the data is not always static. There are always changes down the line, basically. So I think this is also things to consider when working with AI, is that you're building a system that can also evolve with time, basically. So yeah, I think that's what I would say regarding that.
Yeah, very, very super. That's very good point made about the change. I think understanding that is sort of what separates you from a beginner AI engineer, a beginner data scientist, from data scientist or an engineer, AI engineer who knows, what you're doing. Yeah, so I think it's something, it's a concept that we've seen a lot of people miss. And so if you're in this webinar, you get to understand, or you've gotten here today, that if you plan for the drifts and have that as you build, is sort of what separates you from the rest of the pack. Yeah. Thank you so much, Joke.